Electricity powers nearly every aspect of modern life, from our homes and businesses to hospitals, schools, and transportation systems. Behind the scenes, an enormous network of equipment works continuously to deliver electricity safely and reliably to millions of people every day. While power lines and transformers are the most visible parts of this network, today's electrical grid depends heavily on advanced electronic technology that helps monitor, manage, and improve the entire system. Throughout this presentation, we'll explore how smart meters and utility monitoring devices support modern power distribution, why these electronic systems are periodically upgraded, and how proper maintenance, careful planning, and responsible recycling help reduce electronic waste while supporting a stronger and more sustainable energy future. The electrical grid has changed dramatically over the past several decades. Traditional utility systems relied heavily on manual inspections, mechanical equipment, and scheduled maintenance to keep electricity flowing reliably. Today, advanced electronic technologies have transformed how utilities monitor, manage, and maintain the power grid. Modern electrical networks use thousands of digital monitoring devices that continuously collect information from homes, businesses, substations, and distribution equipment. Instead of waiting for routine inspections or customer reports, utility operators can monitor electrical conditions in real time, allowing them to identify problems much more quickly and respond before small issues become larger ones. Digital communication has also improved overall efficiency throughout utility operations. Information from electronic monitoring systems helps utilities evaluate equipment performance, identify outages, analyze energy usage, and make informed maintenance decisions. These improvements reduce response times while helping providers deliver more reliable electrical service. As electrical systems continue becoming more interconnected, the role of electronic technology continues to expand. Automation and digital communication allow utilities to manage increasingly complex networks with greater accuracy than ever before. Although these technologies provide tremendous benefits, every electronic component eventually reaches the end of its operational life. Understanding the complete life cycle of utility electronics encourages thoughtful maintenance, responsible upgrades, and careful management of equipment throughout every stage of its service life. One of the most significant advancements in modern utility infrastructure has been the introduction of smart meters. Installed at homes and businesses, these electronic devices have changed how electricity usage is measured and communicated. Unlike traditional mechanical meters that required utility personnel to perform manual readings, smart meters automatically collect and transmit electricity usage information directly to utility providers. This continuous flow of information allows utilities to better understand energy consumption patterns while improving service planning and operational efficiency. Faster access to accurate usage data also helps utilities respond more effectively to outages, monitor system performance, and support long-term infrastructure planning. Although smart meters appear relatively compact from the outside, they contain sophisticated electronic components that make these capabilities possible. Processors, communication modules, circuit boards, digital measurement systems, sensors, and memory components all work together to collect, process, and transmit important information throughout the electrical network. As communication standards, software platforms, and digital technologies continue evolving, utilities periodically replace older smart meters with newer models that offer expanded functionality and improved compatibility with modern electrical systems. Even when existing meters continue operating reliably, modernization helps utilities prepare for future technological advancements while continuing to improve overall grid performance. Understanding the life cycle of smart meters highlights the importance of maintaining valuable electronic equipment responsibly and planning upgrades carefully to reduce unnecessary electronic waste. Smart meters and utility monitoring equipment are designed to provide many years of reliable service. But like all electronic technology, they eventually become outdated. As the electrical grid continues to evolve, utilities adopt newer systems that offer improved communication, enhanced security, greater accuracy and better compatibility with modern infrastructure. These upgrades help ensure that power networks remain dependable and prepared for future energy demands. One of the primary reasons equipment is replaced is the advancement of communication technology. Modern smart meters can often transmit information more efficiently, support faster data processing, and integrate more easily with updated utility management systems. At the same time, cybersecurity requirements continue to grow, making newer hardware better equipped to protect sensitive operational data and strengthen the reliability of utility networks. Software also plays an important role in modernization. As new applications and grid management platforms are introduced, older hardware may no longer support the features required for efficient operation. In many cases, existing equipment continues functioning properly, but replacing it allows utilities to improve overall system performance and prepare for future technological developments. Rather than replacing equipment simply because newer models are available, utility providers carefully evaluate reliability, operational performance, and long-term value before making upgrade decisions. This thoughtful approach helps maximize the usefulness of existing equipment while reducing unnecessary electronic waste. When people think about electrical substations, they often picture transformers, transmission lines, and large industrial equipment. While these remain important parts of the electrical grid, today's substations also rely on sophisticated electronic systems that continuously monitor, control, and protect the flow of electricity throughout the network. Digital relays, programmable controllers, communication gateways, environmental sensors, monitoring displays, and networking equipment all work together to help operators supervise electrical conditions in real time. These technologies provide valuable information that allows utilities to detect abnormal operating conditions, respond more quickly to potential issues, and maintain safe, reliable power distribution. Automation has also become a key part of modern substations. Electronic monitoring systems reduce the need for manual inspections by providing continuous updates on equipment performance. This allows maintenance teams to identify developing problems before they lead to service interruptions, helping improve both efficiency and reliability. As electrical infrastructure continues to modernize, substation electronics are regularly updated to provide faster communication, enhanced diagnostic capabilities, stronger cybersecurity features, and improved system integration. Although older equipment often remains operational, carefully planned modernization ensures substations continue meeting the changing demands of today's increasingly connected electrical grid. One of the most effective ways to reduce electronic waste within utility systems is by extending the service life of existing equipment through regular maintenance. Preventive care helps utilities protect valuable electronic assets while reducing unnecessary replacements and supporting reliable power distribution. Routine inspections allow technicians to identify loose electrical connections, damaged enclosures, moisture intrusion, excessive heat, or communication problems before they affect system performance. Addressing these issues early helps prevent larger failures that could interrupt electrical service or require costly repairs. Keeping equipment clean and properly protected from environmental conditions is equally important. Dust, moisture, and temperature fluctuations can gradually affect sensitive electronic components if left unchecked. Proper environmental protection helps preserve equipment reliability while extending the lifespan of digital monitoring systems and communication devices. Software updates also contribute to longer equipment life. When available, updated software can improve performance, strengthen cybersecurity, and increase compatibility with modern utility systems without requiring immediate hardware replacement. This allows many electronic devices to continue operating efficiently for additional years. By combining preventive maintenance with thoughtful planning, utilities maximize the value of their existing technology while minimizing unnecessary electronic waste. Extending equipment life not only conserves valuable materials, but also supports a more efficient and sustainable electrical infrastructure. Although smart meters and substation controllers receive much of the attention, they represent only part of the technology that keeps modern utility systems operating efficiently. A wide range of supporting electronic devices work behind the scenes to ensure that monitoring equipment communicates effectively, stores important information, and responds quickly to changing conditions throughout the electrical network. Communication modules, networking switches, backup power supplies, weather sensors, remote monitoring terminals, signal converters, and data loggers all contribute to the performance of the electrical grid. These supporting systems allow utilities to collect operational data, maintain communication between equipment, and monitor environmental conditions that could affect electrical infrastructure. Together, they create an integrated technology network that supports reliable power distribution every day. Because these supporting devices often have different service lives than larger infrastructure components, utilities carefully evaluate each piece of equipment before making replacement decisions. Maintenance history, operational reliability, compatibility with newer technologies, and expected future performance all help determine whether equipment should remain in service or be upgraded. When electronics eventually reach the end of their practical lifespan, responsible management becomes an important part of the replacement process. Utilities often document operational information, identify reusable accessories, and organize retired electronics separately from general construction materials. Working with licensed recyclers allows valuable electronic materials to be recovered while supporting more sustainable management of obsolete equipment and reducing unnecessary electronic waste. The future of electrical infrastructure will continue to be shaped by innovation. As communities demand more reliable electricity, improved efficiency, and greater resilience, smart grid technology will become even more advanced. Future generations of smart meters, monitoring devices, communication systems, and digital substations are expected to provide faster data processing, improved automation, stronger cybersecurity, and more detailed system analysis than ever before. These advancements will allow utilities to respond more quickly to changing energy demands, identify equipment issues with greater accuracy, and improve long-term maintenance planning. Increased automation and better communication between electronic systems will continue strengthening the reliability of electrical service while supporting more efficient operation across the entire power network. At the same time, technological progress means that older electronic equipment will gradually be retired as newer systems are introduced. This makes responsible lifecycle management increasingly important. Extending equipment life through preventive maintenance, carefully evaluating upgrade opportunities, and responsibly managing obsolete electronics all help reduce unnecessary waste while making the best use of valuable engineering resources. Every smart meter, monitoring device, communication module, and substation controller represents significant materials, technology, and expertise. By maintaining these systems carefully and recycling them responsibly at the end of their service lives, utilities can continue building a stronger, smarter, and more sustainable electrical grid for future generations. Thank you for taking the time to learn about the important role smart grid and utility monitoring devices play in modern electrical infrastructure. These technologies have transformed the way electricity is monitored, managed, and delivered, allowing utilities to provide more reliable service while improving operational efficiency across increasingly complex power networks. As technology continues to evolve, thoughtful equipment management remains essential. Regular maintenance, strategic modernization, responsible equipment planning, and recycling obsolete electronics through licensed recyclers all contribute to reducing electronic waste while conserving valuable resources. Every effort to extend equipment life and recover reusable materials helps support a more sustainable and efficient energy future. Reach us by phone, email, or our website. Together, we can support smarter energy infrastructure by responsibly managing utility electronics, conserving valuable resources, and reducing electronic waste for future generations.